Preparing for a Java developer interview. You've reached Interview Guide, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between JDK, JRE, and JVM? JDK is the full development kit, compiler, tools, libraries, and the JRE. JRE is the runtime environment needed to run Java applications. JVM is the engine inside the JRE that loads bytecode, verifies it, manages memory, and executes it. I write code using the JDK, Javac compiles it to bytecode, and the JVM runs that bytecode on any supported platform. While answering, define each component clearly, explain their relationship, mention compilation and execution flow, and connect it to how Java achieves platform independence. Question 2. How does Java achieve platform independence? Java achieves platform independence by compiling source code into bytecode, not native machine code. That bytecode is stored in .class files and executed by a JVM installed for the target operating system. The JVM translates bytecode into native instructions at runtime, often using JIT compilation for performance. So the same compiled Java program can run on Windows, Linux, or Mac OS if a compatible JVM exists. Make sure to cover bytecode, JVM-specific implementations, the role of Javac, runtime execution, and the meaning of write once, run anywhere. Question 3. Explain the main principles of object-oriented programming in Java. The 4 core OOP principles are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation hides internal state using private fields and public methods. Inheritance reuses behavior through parent-child relationships. Polymorphism lets the same interface call different implementations, like list pointing to ArrayList. Abstraction exposes what an object does, not how it does it. Good Java code uses these principles to reduce coupling and make changes safer. In your answer, talk about encapsulation, inheritance, polymorphism, abstraction, practical Java examples, and why these principles improve maintainability and extensibility. Question 4. What is the difference between an abstract class and an interface in Java? An abstract class is useful when related classes share common state or behavior. It can have fields, constructors, abstract methods, and concrete methods. An interface defines a contract and supports multiple implementations. Modern Java also allows default and static methods. I choose an abstract class for a strong ISA hierarchy with shared code. I choose an interface when I want flexible capabilities like comparable, runnable, or serializable. Be sure to mention multiple inheritance of type, default, and static methods, state, constructors, use cases, and when you would choose one over the other. Question 5. Why should equals and hashCode be overridden together? Hash-based collections depend on both methods. If two objects are equal according to equals, they must return the same hashCode. Otherwise, HashMap or HashSet may store or search in the wrong bucket, causing surprising lookup failures. For example, two employee objects with the same ID should compare equal and produce the same hash. I also avoid using mutable fields in these methods because changing them after insertion breaks collection behavior. While answering, explain the contract between equals and hashCode, behavior in hash-based collections, common mistakes, immutability concerns, and a simple example. Question 6. Why is string immutable in Java? String is immutable because it is heavily shared and used in sensitive places like class names, file paths, URLs, and map keys. Immutability makes string pooling safe, so identical literals can share memory. It also makes strings thread safe and allows hashCode caching, which improves HashMap performance. When I need repeated modifications, I use String Builder for single-threaded code, or String Buffer when synchronized operations are required. Make sure to cover string pool reuse, security, thread safety, hashCode caching, class loading, and the difference between String Builder, and String Buffer. Question 7. What is the difference between ArrayList and LinkedList? ArrayList uses a dynamic array, so index-based access is fast because elements are contiguous. Inserts or deletes in the middle can be expensive because elements shift. LinkedList uses nodes with references, so adding or removing at known node positions is cheaper, but random access is slow because traversal is required. In real applications, I usually prefer ArrayList, unless I specifically need queue-like operations or frequent structural changes at ends. In your answer, compare internal structure, random access, insertion and deletion costs, memory overhead, iteration behavior, and practical selection criteria. Question 8. How does HashMap work internally in Java? HashMap stores entries in buckets selected by a hash of the key. On put, it calculates the bucket index, checks for an existing equal key using equals, and either updates or inserts. Collisions are handled with linked lists, and since Java 8, long collision chains can become balanced trees. When size crosses the load factor threshold, HashMap resizes. Immutable keys are safer because changing key fields can make entries unreachable. Be sure to explain hashing, buckets, collision handling, equals checks, resizing, load factor, treeification in Java 8, and why key immutability matters. Question 9. What is the difference between HashMap, LinkedHashMap, and TreeMap? HashMap gives no ordering guarantee and is usually the fastest general-purpose map. LinkedHashMap maintains insertion order or access order if configured, which makes it useful for LRU caches. TreeMap stores keys in sorted order using a red-black tree, so operations are O of log n, not average O of 1. I use HashMap by default, LinkedHashMap when iteration order matters, and TreeMap when sorted range operations are required. While answering, compare ordering guarantees, performance complexity, internal data structures, null key behavior, and typical use cases for each map implementation. Question 10. What is the difference between checked and unchecked exceptions? Checked exceptions are verified by the compiler, so a method must catch them or declare them with throws. They usually represent recoverable conditions, like file or database failures. Unchecked exceptions extend runtime exception and often indicate programming issues, such as null pointer exception or illegal argument exception. I catch exceptions where I can add value, recover, translate, retry, or log with context. Otherwise, I let them propagate to a centralized handler. Make sure to cover compile time enforcement, runtime exception, recoverable versus programming errors, method signatures, and how you decide whether to catch or propagate. Question 11. Explain the Java memory model at a high level. At runtime, Java stores objects on the heap, and method calls, local variables, and references on thread stacks. Class metadata lives in metaspace. The Java memory model defines how changes made by one thread become visible to others. Without proper synchronization, one thread may see stale values. Constructs like synchronized, volatile, final fields, and thread start or join establish happens before relationships, which are critical for correct concurrent programs. In your answer, discuss heap, stack, method area or metaspace, visibility between threads, happens before, synchronization, volatile, and why it matters in concurrent code. Question 12. How does garbage collection work in Java? Garbage collection automatically reclaims objects that are no longer reachable from live references such as stack variables, static fields, or JNI references. Most collectors use generational assumptions. Short-lived objects die young, so the young generation is collected frequently. Long-lived objects move to old generation. Modern JVMs offer collectors like G1, ZGC, and Shenandoah. I reduce GC pressure by avoiding unnecessary allocations, leaks, and oversized object graphs. Be sure to mention reachability, generations, minor and major collections, stop the world pauses, common collectors, and how developers can reduce GC pressure. Question 13. What is the difference between stack memory and heap memory? Stack memory is per thread and stores method frames, local primitives, and object references. It is fast and automatically cleaned when methods return. Heap memory is shared across threads and stores actual objects and arrays. Heap objects live until they become unreachable and garbage collected. A deep recursive call can cause stack overflow error, while retaining too many objects can cause out-of-memory error. Understanding both helps diagnose performance and memory issues. While answering, contrast lifetime, allocation, ownership, thread visibility, what gets stored where, performance characteristics, and common errors like stack overflow error and out-of-memory error. Question 14. What is the difference between synchronized and ReentrantLock? Synchronized is built into the language and automatically releases the monitor when the block exits, even on exceptions. ReentrantLock is more flexible. It supports try-lock, timed waits, interruptible locking, optional fairness, and multiple condition objects. The trade-off is that I must release it in a finally block. I use synchronized for simple mutual exclusion and ReentrantLock when I need advanced control over lock acquisition or waiting. Make sure to compare intrinsic locks, explicit locking, fairness, try-lock, interruptible locking, condition variables, readability, and when simpler synchronized code is preferable. Question 15. What does the volatile keyword do in Java? Volatile guarantees visibility. When one thread writes to a volatile variable, other threads reading it see the latest value. It also prevents certain instruction reordering around that variable. But volatile does not make compound actions atomic, so count++ is still unsafe. I use volatile for simple state flags, like stopping a worker thread. For counters or coordinated updates, I prefer atomic integer, locks, or higher-level concurrency utilities. In your answer, explain visibility, prevention of certain reorderings, lack of atomicity for compound operations, suitable flags, and comparison with synchronized or atomic classes. Question 16. How would you create and manage threads in Java? For small examples, I can create a thread with a runnable, but production code should usually use executor service. A thread pool controls resource usage, reuses threads, and separates task submission from execution. Callable returns a result through future, unlike runnable. I also shut executors down gracefully with shutdown or shutdown now, and handle task exceptions carefully. Directly creating many threads can exhaust memory and cause context switching overhead. Be sure to cover thread, runnable, callable, executor service, thread pools, future, graceful shutdown, exception handling, and why direct thread creation is often avoided. Question 17. What are common ways to avoid race conditions in Java? Race conditions happen when multiple threads access shared mutable state, and at least one modifies it without proper coordination. I prevent them by making state immutable, confining it to one thread, or guarding it with synchronized blocks or locks. For counters, I use atomic integer, or long adder. For shared collections, I prefer concurrent HashMap or blocking queues. The best design often reduces shared state instead of adding more locking everywhere. While answering, discuss shared mutable state, synchronization, locks, atomic variables, concurrent collections, immutability, thread confinement, and designing for minimal coordination. Question 18. What is the difference between fail-fast and fail-safe iterators? Fail-fast iterators detect structural modification after iteration begins and throw concurrent modification exception on a best effort basis. ArrayList and HashMap iterators behave this way. Fail-safe style iterators, like those from concurrent HashMap or copy-on-write ArrayList, allow concurrent modification by using weakly consistent views or snapshots. They avoid exceptions but may not reflect every latest change. I choose based on whether I need strict consistency or safe concurrent iteration. Make sure to explain concurrent modification exception, structural modification, examples from ArrayList and concurrent HashMap, snapshot behavior, and consistency versus performance trade-offs. Question 19. How do Java streams differ from collections? A collection stores data. A stream processes data. Streams provide a pipeline of operations like filter, map, sorted, and reduce. Intermediate operations are lazy and execute only when a terminal operation, such as collect or count, runs. I use streams for clear data transformations, especially when chaining operations reads naturally. I avoid overusing them for complex branching logic, where a normal loop is often easier to debug and maintain. In your answer, cover data storage versus processing pipeline, lazy intermediate operations, terminal operations, functional style, parallel streams, and when streams can hurt readability. Question 20. What are functional interfaces, and lambda expressions in Java. A functional interface has exactly one abstract method, which makes it a target for a lambda expression. Examples include runnable, comparator, predicate, function, and consumer. Lambdas let me pass behavior as data, such as sorting users by age with comparator.comparing, user.getAge. The @functional interface annotation catches accidental extra abstract methods. Captured local variables must be effectively final, which prevents confusing mutation from inside lambda bodies. Be sure to mention single abstract method, @functional interface. Common interfaces like predicate and function, method references, cleaner callbacks, and limitations around captured variables. Question 21. How do generics work in Java, and what is type erasure? Generics give compile time type safety. For example, list string prevents adding an integer and removes the need for manual casts when reading. Java implements generics using type erasure, meaning most generic type information is removed at runtime for backward compatibility. That is why I cannot directly create new T or check obj instance of list string. Wildcards like x extends number and x super integer help design flexible APIs. While answering, explain compile time type safety, parameterized types, wildcard bounds, erased runtime types, limitations, and why generics reduce casting errors. Question 22. What is optional and how should it be used? Optional is a container that represents a value that may or may not be present. It makes absence explicit and encourages handling it through methods like map, flatMap, or else, and or else throw. I typically use optional as a return type when no result is valid. I avoid using it for fields, method parameters, or collection elements in most cases. Also, or else evaluates eagerly, while or else get is lazy. Make sure to cover representing absence, avoiding null checks, map and flatMap, or else versus or else get, return type usage, and when optional is not appropriate. Question 23. How does dependency injection work in Spring? Dependency injection means an object receives its dependencies instead of creating them directly. In Spring, the container creates beans and wires dependencies using annotations like @component, @service, @repository, and @autoard. I prefer constructor injection because it makes required dependencies explicit, supports immutability, and simplifies testing. This improves loose coupling. A service can depend on an interface, while Spring provides the actual implementation at runtime. In your answer, connect dependency injection to inversion of control, bean creation, constructor injection, testability, loose coupling, scopes, and common annotations. Question 24. How would you design a REST API in a Java Spring Boot application? I start by modeling resources clearly, then map operations to HTTP methods, get for reads, post for creation, put or patch for updates, and delete for removal. In Spring Boot, I expose controllers, validate input with bean validation, and use DTOs to avoid leaking entities. I return meaningful status codes and centralize errors with @controller advice. For production APIs, I add pagination, authentication, idempotency where needed, logging, and versioning. Be sure to mention resource modeling, HTTP methods and status codes, validation, DTOs, exception handling, pagination, security, idempotency, logging, and API versioning. Question 25. How do transactions work in Spring and Hibernate? In Spring, @transactional defines a boundary around a method. Spring opens or joins a transaction. Hibernate manages a persistence context, and changes to managed entities are detected through dirty checking. On successful completion, changes are flushed and committed. On runtime exceptions, rollback happens by default. Propagation controls how nested calls behave, and isolation controls visibility between transactions. Common pitfalls include lazy loading outside a transaction and self-invocation bypassing proxies. While answering, explain @transactional, persistence context, commit and rollback, propagation, isolation, lazy loading, dirty checking, and common pitfalls like self-invocation. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.